we are going to start talking about Isaac Newton, or Sir Isaac Newton, and his 3 laws of motion. His first law of motion, which we call the law of inertia, really builds off of the last 2 scientists that we talked about. So Aristotle, he told us that if you push on something, it moves. If you don't push on something, it doesn't move. Galileo started talking about this even more, saying the inertia is a property of matter that causes it to resist a change in motion. So basically, the heavier something is, the more it resists a change in motion. But it's still, that object likes to do what it was already doing. If it was sitting still, its inertia will keep it sitting still. If an object was moving, its inertia will keep the object moving. Isaac Newton kind of expanded on this a little bit. He broke it down into 2 distinct parts. The first part of Newton's first law was an object at rest will remain at rest unless an external unbalanced force acts upon it. What that is saying is, this object is going to stay at rest unless an unbalanced force pushes it. Unbalanced means that it's only coming from like one side. So if I push it here on the right, it is going to the left. If I push it on the left, it is going towards the right. If I had a balanced force on it, it's not going to go anywhere because it is balanced. It's pushing the same amount to the left as it is to the right. Part 2. An object in motion will remain in motion at a steady speed along a straight line path unless an external unbalanced force acts upon it. So, I like to use the ball example. So this ball is going to keep rolling unless something acts against it. So unless something gets in its way, that ball is going to continue to move in a straight line. Now, I know a few of you are thinking right now, well, if a ball rolls along the ground, eventually it stops. This is true. But in that case, the force that's acting against it is friction. So like just the ground pushing against it or the air pushing against it as it goes. It takes a long time to stop, but it will stop eventually because of that unbalanced force. We like to break down Newton's first law and basically say that objects are lazy. So they like to keep doing whatever it is they're doing. An object at rest will remain at rest. An object in motion will remain in motion. Newton's second law. They're talking about unbalanced forces and how much acceleration they get from that force. Basically, the bigger the unbalanced force on an object, the greater its acceleration will be. That means the harder you push on something, the faster it will accelerate. I like to think about cars. I'm a car guy. If you take a car and you put a bigger motor in it, you're giving it a greater force, it is going to accelerate at a greater rate. Part 2 of this is talking about mass. And they say the greater the mass of an object, the smaller its acceleration will be. This makes sense as well. If you have the same motor in a little teeny tiny Cavalier or a Sunfire, and you put that same motor in a semi-truck, which of those 2 vehicles do you think is going to accelerate more or have a greater acceleration? It's going to be the car that is lighter. You can also think about it here. We've got a fridge. If I go ahead and take out my trusty thing of tape again, I can make this tape accelerate very easy with a little bit of force. If I pushed on a fridge with that same amount of force, it's not really going to accelerate because it has such a greater mass. So the big takeaway from Newton's second law, big force means big acceleration. Therefore, small force is small acceleration. Then when we start talking about mass and acceleration, a big mass means it has a small acceleration. And the inverse of that would be a small mass has a big acceleration. Now the last one we talk about is one that kind of confuses people a little bit. And that's Newton's third law. For every action force, there is an equal and opposite reaction force. So basically, if when you push on something, it pushes back on you with the exact same force. The example I like to talk about here is probably how angry all of you got when school was canceled. And you got so angry and you found the first wall or the first piece of metal that you could see and you just wailed on it with your arm. Now, you probably put a dent in that wall just because you're such big, strong people. But that wall also hurt your hand, because when you hit something, that wall hits you back. We get on to the next page here to really talk about how this affects our motion. So, if we take a look over here, let's take a look at this skateboarder. He's going along the street. We often think that we're pushing ourselves forward when we're moving, but if we actually take a closer look, that's not what's happening. This skateboarder here, his foot, he is pushing backwards on the ground, but because he pushed on the ground did an equal and opposite reaction force to him, which pushed him forward. So you push backwards on the ground pushes back on you to make you go forwards. This man pushed backwards, the ground pushed forwards, and it moved along. So what direction are we really pushing with our foot? And then what are we really pushing on? So we are pushing backwards, applying a force to the ground. So what is actually pushing us forward? So in return, the ground applies a force to us, pushing us forwards. Now, when we know this, it reminds us that only external forces can change an object's motion. So something else has to push on an object to make that object move. So people can't push themselves forward. They have to push on something else that will then push them forward. Rockets can't push themselves upwards. The rockets are pushing on the air below them, which is then propelling them forward. And a car can't apply a force to make itself stop. It has to be the asphalt that they're driving on that applies the force to them to make them stop. This is why it takes longer to stop on ice compared to like the bare street, the regular asphalt or pavement, because the ice can't apply as big of a force to you as the asphalt can. In all of these cases, we push on something else and then it pushes back on us in the direction we want to go. Newton's third law makes us go, or stop actually. It allows us to change our motion. So here, you had to draw an arrow showing the force acting on each object that is causing its motion, and state what is applying the force to the object. Kind of a weird way to think, so give yourself time to figure this one out. In this case, the object is the skier. Now, what is it? Sorry folks, I'm getting a lot of messages on Teams. Okay, so what is it? The object is the person. It is the ground that is applying a force to the object, and the ground is applying a force in this direction to the left because the person is moving to the left. With our basketball player, the object is the basketball player. The ground applied a force upwards, which made the basketball player move upwards. In this third example, the object we're looking at is the car. It is the pavement that's going to apply a force to the car, and the pavement is going to push backwards on the car to make it stop at this stop sign. Here we have a swimmer. So our swimmer is the object. The water is going to be applying a force to the swimmer, and it's going to be applying a force forwards to make the swimmer move forwards. So as you're swimming, you're cupping the water, you are pushing backwards on the water, and because of Newton's third law, the water is doing an equal and opposite reaction force and pushing you forwards. Here we have a cheetah that's getting, probably getting lunch. So the cheetah is moving forwards. It is the object. It is the ground that's going to apply a force to the cheetah. The ground is going to apply a force forwards, propelling the cheetah forwards, maybe towards the gazelle, I don't know. And then finally, we have, looks like a hawk, something. Now this bird is going to be the object in question. This bird is going to be moving up. The way this bird moves up is it flaps its wings down, which pushes on the air. So the air applies a force to the bird's wings. It applies a force upwards on the bird to make it go up. The rest of this package is going through scenarios. Go ahead and take a read through these. Keep your notes handy. Take a really good look at what each law is telling you and try to apply each law to all of these different scenarios. We will be posting a self-correction PDF for this probably tomorrow. So do the work now, try to figure out what you know, and then do the corrections tomorrow. Thanks, guys.